Welcome to EDU World Space.
In this exercise, we have a car that has a mass of 1.5 megagrams, which is the same as 1500 kilograms, and has a tractive force of 4.5 kilonewtons. And in the figure, we have the information that the speed of the car as a function of time, v, is equal to minus 0.05 t squared plus 3t. And our goal is to find what is the value of the resistance force, that is the air resistance, as a function of t. Notice that, again, according to the figure, we have that the resistance force is pointing opposite to the tractive force. Okay? So basically, in order to solve this exercise, all we need is Newton's second law that tells us that the sum of the forces, that is the net force, on a body is equal to its mass times the acceleration of that body. Now, the forces that act on the car are F and R, and since they're opposite in direction, we have the total force is F minus R, and this is equal to the mass of the car times the acceleration. Notice that here I'm only considering the one-dimensional case, where the x direction is pointing to the left. Okay. Now remember that the acceleration a is equal to the first derivative of the speed with respect to time. So we can find the acceleration from the velocity formula. So we have d dt of minus 0.05 t squared plus 3t. Now remember that the derivative of t squared is 2t, so a is minus 0.1 t, and the derivative of t is just 1, so plus 3. This is in meters per second squared. Okay. And now we can find r in this formula here. We can isolate r. So we have that F minus ma is equal to r. F, the tractive force, is 4,500 newtons. And we have to subtract the mass, which is 1500 times minus 0.1 t plus 3. So this is 4,500 plus 150 t minus 4,500. So this is just equal to 150 t, and this is equal to the resistance, the air resistance. The exercise asks us to plot this. Notice that this is just a line that starts at 0, okay, and reaches, after a time t of 30 seconds, it reaches a value of 4,500 newtons. And this is the answer to our exercise.